SO2Cl2 is called as sulfuryl chloride. Positive value you have to take it as cathode and the negative value you have to take it as anode. Question paper. We'll see with the 21st question. The number of optical isomers of the compound CH3CHBr CHBr COOH is 0, 1, 3, 4. So how many optical isomers it can form? First we will see the structure. It is CH3CHBr. I can write Br on the other side, H on the other side, and then it is COOH group. If you observe this, there is no plane of symmetry. And how many chiral or asymmetric carbon atom is there? We have 1 and 2. Thus, the number of optical isomers is A is equal to 2 to the power n, where n is number of asymmetric carbon atom. So it is 2 to the power 2, that is 4. So we will get 4 optical isomers for this compound. But we need to take care that there is no plane of symmetry. As there is no plane of symmetry, we can go with the answer 4, that is option D. Okay. 22nd question. When limestone is heated, carbon dioxide is given off. The metallurgical operation is option A, smelting, option B, reduction, option C, calcination, option D, roasting. So it is limestone CaCO3 when it is heated, get calcium oxide as well as carbon dioxide is liberated. So you can see it is heated in the absence of air and carbon dioxide is produced. So it should be calcination process. Okay. So next question. The rate of reaction increases with rise in temperature because of option A, increase in number of activated molecules, increase in activation energy, option C, decrease in energy of activation, option D, increase in number of effective collision. So when we are going to increase the temperature, what is happening? The number of activated molecules will increase. So there is increase in number of activated molecules. Because there is increase in number of activated molecules, also there will be increase in number of effective collision. So we have 2 right answers here, that is option A and option D. Okay. So this question has 2 correct answers. Increase in number of activated molecules and increase in number of effective collisions. So I hope you have understood. Next question. Meso compounds do not show optical activity because they do not contain chiral carbon atom. They have non-superimposable mirror images. Option C, they contain plane of symmetry. Option D, they do not contain plane of symmetry. Meso compounds, they do not show optical activity. Why exactly they do not show optical activity? That is because they contain plane of symmetry. Even if there are chiral carbon atoms, they do not show optical activity because of the presence of plane of symmetry. Okay. So I hope you understood what is meso compounds. Next one. When formic acid is heated with concentrated H2SO4, the gas evolved is option A, only carbon dioxide, option B, only carbon monoxide, option C, a mixture of carbon monoxide and carbon dioxide, option D, a mixture of sulfur dioxide and carbon dioxide. So what are we heating here? Formic acid. So formic acid is HCOOH. When it is heated with what? Concentrated sulfuric acid, H2SO4. So what do you get? It is carbon monoxide which is formed and water is removed. So what is formed? Only carbon monoxide. That is option B. Okay. Next question. Temperature coefficient of the reaction is 2. when temperature is increased from 30 degrees Celsius to 90 degrees Celsius, the rate of the reaction, option A, increases 60 times, option B, 64 times, option C, 150 times, option D, 400 times. So how much is the increase in temperature? That is 90 degrees Celsius minus 30 degrees Celsius. They have increased by 60 degrees Celsius. So for every 10 degree raise in temperature coefficient is 2. So 60 times means how many times have they increased? 6 times they have increased. So you have to do, as the temperature coefficient is 2, it is 2 to the power 6. So 2 to the power 6 is how much? 2 to the 4, 4 to the 8, 8 to the 16, 16 to the 32. 32 into 2 is 64. So it is 64 times. So answer is option B. 64 times the rate of the reaction will increase. Okay. Next question. Conversion of benzene to acetophenone can be brought by Wood's reaction, Woods-Fittig reaction, Friedel-Crafts alkylation, Friedel-Crafts acylation. So what do we need? Benzene we have to convert into acetophenone. Acetophenone is COCH3 group it has got. Okay. So what is this? I can do with CH3COCl in the presence of anhydrous aluminium chloride. So which is this reaction? It is Friedel-Crafts acylation reaction, because we are adding COCH3 group, isn't it? So the answer is option D. Alkylation means it will be only CH3 group which will get added and you will get toluene. And Woods-Fittig reaction cannot happen on benzene, isn't it? Woods reaction also cannot happen. So it should be Friedel-Crafts acylation reaction. So we'll see the next question now. Excess of PCl5 reacts with concentrated H2SO4 giving chlorosulfuric acid, sulfurous acid, sulfuryl chloride and thionyl chloride. So we'll write the equation and see. When PCl5 is reacting with concentrated H2SO4. So what we are going to get here is SO2Cl2 plus POCl3 and HCl. Here I have not balanced the equation, but we are getting SO2Cl2 and SO2Cl2 is called as sulfuryl chloride. So the answer is sulfuryl chloride. Okay, option C. Next question. An example for neutral buffer is ammonium hydroxide and ammonium chloride, acetic acid and sodium acetate, acetic acid and ammonium hydroxide, citric acid and sodium citrate. Here if you see, you have acetic acid and sodium acetate and citric acid and sodium citrate. Both of these are acidic buffers. But here you can see option A, ammonium hydroxide and ammonium chloride. This is basic buffer, isn't it? But they are asking us neutral buffer. Yes, acetic acid and ammonium hydroxide will form neutral buffer. That is why option C is the right answer. Okay. Next question. Least energetic conformation of cyclohexane is, that is chair conformation, because there is less angle strain, isn't it? In cyclohexane we have chair and boat conformations, correct? Chair conformation is having least energy because that's the most stable, as it has got less angle strain. Okay. But if you see the options, we have chain conformation, boat conformation, cis conformation and E to Z form. We do not have the answer chair conformation at all. Maybe it was a spelling mistake. It should have been option A. Instead of chain, it should have been chair conformation. But then because we do not have this option here, this is allotted grace marks. Okay, and the answer is chair conformation, okay, which has got least energy because that's the most stable one with less angle strain. Okay, next question. Which of the following is employed in flash tubes in photography? Argon, neon, krypton, xenon. Here again we have two correct answers, that is krypton and xenon. Both are used in flash tubes in photography. Okay. Next question. Conjugate base of H2PO4 minus is. See, if I want a conjugate base, that means this should be an acid, isn't it? An acid will lose H plus ion. So here H2PO4 minus, if it loses one more H plus ion, I will get it as HPO4 2 minus plus H plus. So this is the conjugate base. So which is the correct answer? Option B, HPO4 2 minus. This should be an acid. That's why it is losing one H plus ion to form a conjugate base. So I hope I am clear. Okay. None of the other options will match our answer. Correct? Okay. Next question. An alkyl bromide X reacts with sodium in ether to form 4,5 diethyl octane. The compound X is. So what is it? Some alkyl bromide is there which is called as X. That undergoes Wood's reaction. You can see sodium with ether. That means it is Wood's reaction to give an alkane. This is the alkane which is formed. So we have to find out which is that alkyl bromide which is reacting. What we can do is we write the product and see where exactly the link can be formed. So here you can see the structure of the product. 1, 2, 3, 4, 5, 6, 7, 8. Okay. 4 and 5, 1, 2, 3, 4. 4 and 5 should have an ethyl group. So it is CH2, CH3 group, CH2 and CH3 group. Okay. And then remaining I shall fill. This is CH3, CH2, CH2 and this is CH, this is CH, CH2, CH2 and CH3. Now I'll break this molecule into two equal halves. You can see it can be done over here. So this should be my one molecule where with one bromine atom here. This should be my another molecule with bromine atom here, in which the Wood's reaction is happening, and then this link is formed, this bond is formed. So I have to search for 1, 2, 3, 4, 5, 6 carbon atom chain in which the fourth carbon atom is having bromine. Okay. So we'll see. First one we have 3 plus 1, only 4. It is not possible. 5 plus 1, 6 is there, but bromine is in the first carbon atom. So it's not possible. Here if I see 1, 2, 3, 4, 5, 6 is there, but bromine is in the second carbon atom, which is not possible. So it should be option D. Here you can see 1, 2, 3, 4, 5, 6. And bromine atom, if I count from here, there is 1, 2, 3, fourth carbon atom, bromine is present. So obviously this should be the correct answer, option D. Okay. Next one. Which one of the following shows highest magnetic moment? Fe plus 2, CO plus 2, Cr plus 3 and Ni plus 2. So here, which has the highest magnetic moment, they are asking. Highest magnetic moment means they should have highest unpaired electrons. Correct? So the first one is Fe plus 2, which I have got. Fe plus 2 state, it is D6 system. D6 system means how many unpaired electrons will be present? 1, 2, 3, 4, 5, 6. So 4 unpaired electrons. CO plus 2 is, we cannot write here the number of unpaired electrons, it's not a metal. Cr plus 3. Cr plus 3 state is 3 system. So it has got 3 unpaired electrons, isn't it? 1, 2, 3. Correct? So it has got 3 unpaired electrons. Ni plus 2 state, it is D8 system. And how many unpaired electrons will be there in D8? 1, 2, 3, 4, 5, 6, 7, 8. Only 2 unpaired electrons. So which has got the highest number of unpaired electrons in Fe plus 2? So the answer is Fe plus 2 state, which has got highest magnetic moment. Okay. Now in this question, if you consider this O to be small letter, okay, CO, that means it will be cobalt, isn't it? Cobalt in plus 2 state, if I do consider it to be cobalt also in plus 2 state, it will be D7 system, in which how many unpaired electrons? 1, 2, 3, 4, 5, 6, 7. You'll have 3 unpaired electrons. Even then, this will not be the correct answer. Okay. But then here they have given C and O in also is capital. So it is mistake which is there in the question paper. Okay. We'll see the next question. The EMF of galvanic cell constituted with the electrodes zinc, that is Zn plus 2 with Zn is minus 0.76 volt and Fe plus 2 with Fe is minus 0.41 volt is. You have to find out the EMF of the cell. We know that EMF of the cell is E naught of cathode minus E naught of anode. The one with the higher value, if there is one is positive and one is negative, positive value you have to take it as cathode and the negative value you have to take it as anode, isn't it? But here you have both negative, so the higher negative value will go as anode and the lower negative value will come as cathode. So you will get it as minus 0.41 minus 0.76. So it will be minus 0.41 minus into minus plus, it is 0.76. So the value will be plus 0.35 volts. So the answer is option C. Okay. So next question. Which of the following pair is correctly matched? Rx with AgOH will give RH. This is wrong. Rx with AgCN will give RNC. This is right. And then Rx with KCN will give NC. This is wrong. And Rx with Na, that is sodium, in presence of ether, then this is right. So we have 2 and 4 which is correct. So we have to see the options now. 1 alone is correct. 1 and 2 is correct. That's wrong. 2 and 3 is correct is wrong. 2 and 4 are correct. So option D is the correct answer. Okay. Next question. In a transition series, with the increase in atomic number, the paramagnetism increases gradually, decreases gradually, first increases to a maximum and then decreases, first decreases to minimum and then increases. So as the atomic number increases, what happens to paramagnetism? Paramagnetism depends on the number of unpaired electrons, isn't it? So if you go along the period, for example, if I take 3D transition series, what is happening? The number of unpaired electrons increases. First it is 1, then 2, then the number is 3, then it is 5, then it is again 5, then it will be again 4, then 3, then 2. It will go on reducing, isn't it? So what is happening? The number of unpaired electron is increasing, then it is decreasing. So if paramagnetism first increases, reaches up to maximum and then decreases. So it is option C. First increases to maximum and then decreases. So option C is correct. Okay. Next question. Identify a species which is not a Bronsted acid but a Lewis acid. What is Bronsted acid? It should give away H plus ion. What is Lewis acid? It should be able to accept an pair of electron. Correct? So we have to see which is not a Bronsted acid but it's a Lewis acid. Options, we have option A BF3, option B H3 plus O, and option C NH3, option D HCl. So HCl we know it's a Bronsted acid. H3O plus also it is taken up an H plus ion. Water molecule is taken up an H plus ion, isn't it? So here it can give away also one H plus ion, so it can be considered to be an acid. NH3 has a lone pair of electron, so it can give away to form a Lewis base there because it is donating a pair of electron. The answer should be BF3 because there is no H plus ion to behave like Bronsted acid, but boron is not completed its octet. It can accept a pair of electron and act as a Lewis acid. So I hope you have understood. BF3 is not a Bronsted acid but it is a Lewis acid as it can accept a pair of electron. So we'll see the next question. The compound formed when calcium acetate and calcium formate is dry distilled is acetone, acetaldehyde, benzaldehyde, acetophenone. So what is it? When calcium acetate and calcium formate is distilled, what is the product formed? I'll write the reaction here. CH3, COO, Ca, COO, CH3. This is calcium acetate. Calcium formate I shall write. Okay. OOCH. Okay. Now what is removed from here? CaCO3. So we'll have to remove two molecules of CaCO3. So what we will get here? If CaCO3, CH3, CHO. So I'll get CH3, CHO, two molecules, and CaCO3 is removed. That is two molecules of calcium carbonate is removed. So what is this? This is acetaldehyde. So option B is the right answer. Okay, we'll see the next question. D2sp3 hybridization of the atomic orbital gives square planar structure, triangular structure, tetrahedral structure, octahedral structure. D2sp3 hybridization will give octahedral structure. So option D is the correct answer.